Okay, so now we're going to tie in the slope fields that we did with differential equations. We've dabbled a little bit in differential equations. So none of this is new today, other than one small thing that I'm going to really hammer home, which I haven't focused on very much yet, but is incredibly important. So almost always, I should say, let me rephrase that. On the last couple of years, the AP test has included the type of problem that we're going to talk about today. And it's broken into two simple parts. They give you a derivative. They ask you to graph the slope fields, and normally not as big as the ones we've been doing. They usually ask you for like 6 to 10 dashes so that you can demonstrate that you know what's going on. And then they ask you to solve the differential equation. We did the slope fields yesterday. We're going to do the differential equations today. And there's one little tidbit in there that's really important. So as we talked about, the AP questions are 9 points. The slope field part of that question is usually about 2 points. And then the other 7 points are involved in this differential equation stuff. That's a lot of points. The weird thing is if you don't do this separable thing, which I'll get to in a second, they give you 0 out of 7 points. It's really harsh. Simple solution, just remember to do it. Okay? And it's something that I haven't been focusing on too much. So we're not, like I said, this isn't anything new today. It's just doing more of what we should do. So differential equations, we'll talk about using initial conditions, comparing general solution to particular solution. So general solution would be the entire slope field. Particular solution would be one special curve that you drew through a certain point. We talked about slope fields already, and of course you should be able to drive a stick shift car. How many people can drive a stick shift car? That's it, huh? Ooh. What does this mean?
Not well.
So maybe you shouldn't drive a stick shift car. Okay. All right. Good safety tip. Okay, blah, 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 blah. Great. Let's move on. First scenario.
I agree.
Yeah, I mean, we talked about everything that was on that slide anyways, talking about differential equations, how they relate to slope fields. First type of question is looking at a differential equation. I gave you the differential equation already. It's right here. Y prime minus y equals 0. Where did that come from? Just made it up. And I want to know if sine of x satisfies that condition. Okay, so this isn't rocket science. What do I need to do? So
find y double prime of sine x.
Good. In order to find y double prime, I need to find
Y prime.
y prime. So find y prime, find y double prime, and then what?
Plug it in.
Beautiful. Done. Okay. There's y prime, there's y double prime, plug it in. So y double prime is negative sine of x. Y is sine of x. Subtract the 2, I get negative 2 sine of x, which is not equal to 0. So nope, it doesn't work. It's not a solution to that differential equation. And you're all fairly bright. I have 2 examples. If one of them doesn't work, you can pretty much guess the other one will work. What's a derivative of c e to the x? Yep. C e to the x. It's its own derivative. So therefore, the second derivative would be c e to the x. The pattern repeats itself. So there are the 2 derivatives. They're identical. So if you subtract them, you will in fact get 0. Yay! It's a solution. One works, one doesn't work. That's not the exciting stuff. This is the exciting stuff. We want to solve a differential equation. There's our differential equation. dy over dx equals 2x cubed minus 3x. When we solve the differential equation, what can you tell me about the function I'm going to get when I finish this? Okay, let's take baby steps. What kind of function is that?
It's cubic.
It's a cubic. And when I solve for the function whose derivative gave me a cubic, what kind of function will I get?
Quartic.
A quartic, correct. 4th power. So that's kind of a little preemptive strike there as to what we should get for an answer. Okay, now this is the important part. These are called separable differential equations. And I've been really loose when we've been doing the integrals that I've kind of mentioned it, but I haven't really been hyping on it like I should. And that is every integral needs a differential. Remember the differential is that dx thing. the dx, the dt, the dy, whatever it is you're working with, why does that differential need to be there? What purpose does it serve? Max? Sorry, I got you mid-drink.
Helps define which variable.
Good. Helps define the variable. And there are integrals that you can do where you'll have multiple variables, but we need that differential there because it tells us which of those letters is actually the variable. So when solving a separable differential equation, you have to do just that. You have to separate the differentials. dx's go on one side, dy's go on the other. And that's the little step that you need to include. If you forget that little step, no points. And it's really harsh. I don't really understand why they're so harsh about it, but it happens. Okay, so you need to do that first. Put the dx over on the other side with all the x's. Put the y's and the dy's on the other side so that those two don't play well together. What do I do next to get y by itself? And take the integral of both sides. Michael, what's the integral of dy?
Y.
Good. And what's the integral of 2x cubed minus 3x?
1/2 x to the 4th minus 3/2 x squared plus c.
Plus c. Very good. Okay. Now, why isn't there a plus c on the left side? Should I have a plus c on the other side, Mike?
I mean, you could have it, but if you subtract c from that side, it just equals c.
Well done. Does everybody follow that? Technically speaking, if I was just doing the integral of dy, I should have y plus c. But as he said, if I have a c over here and a c over here, and I move this c over there, what's c minus c?
0.
No. C, correct. So here's what we're going to agree on. We're going to skip that step. What did I do now? You just having one of your maniacal fits again?
It wasn't just me!
You're the only one I heard laugh.
Well, I mean, it's hard to hear. Sorry. It was so mean. I'm so sorry. I'm so sorry.
I don't know.
That was lovely.
I'm really sorry.
I don't take it personally, it's fine.
I have really loud laugh too, so I get it. Don't worry.
I didn't even hear you. I speak from
You guys just fight right now. That would be awesome.
I just saw Mr. Reed going there, and I was like,
She could laugh and you could sneeze. I should have gotten involved. I'm sorry. I should have remained Switzerland in that one. But, okay, so where were we? Oh, C's on both sides. So we'll just agree we don't need two C's, and the standard will be we'll attach the C to the X term. Okay, that'll make our lives a little bit easier. It'll chop out one of the steps. General solution. How do you know that? Because it says general solution, but it also has a C term in it. The next example, I want to find the particular solution. Okay? In other words, I want to solve for C. Are we good so far? All right. As I said, you must separate the differentials. Okay, so that looks familiar. We did that. Come on, Reed. Slope field yesterday involving that function. And what did the slope field look like? It was a circle. So hopefully, if I do this correctly, that's a big if, I should get a circle when I'm done. Okay. So separate the differentials. I'm going to bring the dx over here. I'm going to leave the dy on that side, but I need to bring the y over to the other side. In other words, I'm going to cross multiply in this case. Y dy is equal to negative x dx. I could have taken the negative sign with the y. I could leave it with the x. It doesn't matter. Everything will work out in the end. Doesn't matter where you want to put that constant. Integrate both sides. What's the antiderivative of y? Dominica, help me out. What's the antiderivative of y? Fine, no problem. How about negative x?
-1/2 x squared
Beautiful.
plus
Good. And we agree to stick the plus c on the x side. Okay. There's my general solution, but you'll notice in the example, or in the directions, it gives you some information about the initial condition. In other words, now I want to solve for the particular solution using the fact that it passes through the point 1, 1. Plug that into the function. I get 1/2 equals negative 1/2 plus c, so c equals 1. Okay, and we can clean this up a little bit to get where we need it to go. Technically speaking, we should solve for y because we're looking for a function, but just to show how it matches with the other one, I would do the following. Move the x squared to the other side. And then get rid of the 2. Or get rid of 1/2, I should say, by multiplying by 2. That should look familiar. Yes? What's that in the equation for? Circle. With a center at 0, 0 and a radius of? No. Square root of 2. Very good. Okay. One particular solution, if you recall the slope field yesterday, it was an infinite number of circles. The only thing that determines that we're talking about this particular circle is the initial conditions. Okay. I could change the initial condition, I would get a different circle. Still centered at the origin, only a bigger or smaller radius depending on the circle. Okay. So in order to solve for the particular solution, you need to have some initial conditions. And or you need to know what point it passes through. They're the same thing. Any problems? Like I said, no big deal here. It's nothing that we haven't done already, except you got to remember to separate these differentials, or you're going to be in a world of hurt. dx is on one side, dy is on the other.
So we have to do this like for every differential equation we solve, or?
Yeah. It's just taking integrals. Yeah. The only difference is a lot of the ones we've done already was just, you already had it as dy dx. We took the integral of both sides and got sloppy. Now you need to clean it up. Okay. Slope fields we did already. This is an example of an AP style question that you would see. They would give you a derivative, something fairly reasonable. They would give you a slope field grid, and usually it's not that many dots. You wouldn't have to fill in that many dots. They would ask you to draw in a couple dashes. So put in 6 to 10 to 12 dashes in there to demonstrate that you know how to work with a slope field. Then you go and do all this stuff. And this stuff is solving the differential equation. You got to solve the differential equation by separating the differentials, solve it for y, and then in this case use the particular solution for 2, 1 to figure out what that function is. We're not going to do that, but I wanted to show you what that looks like. And I've got a couple more for you to practice later on in the chapter when we get to the day that says AP or AB test prep questions, whatever. There's a couple examples of these on there because almost guaranteed it's going to show up on the test because it has for the last couple of years. Questions? Outstanding. We're all done. There's a bunch of nerds in the parking lot making a slope field.
Would you do that after the AP test?
No.
No.
Please no.
No, you don't want to go out in the parking lot?
I have no desire.
No? It would be so much fun.
That'd be exciting.
Wow, okay, I get it.
All right, there's more food over here.
I
Help
get
yourself.
it.